A warm welcome to the 21st lecture on the subject of digital signal processing and its applications. We continue in this lecture to discuss the subject of filter design and specifically infinite impulse response filter design. We need to recapitulate a few ideas before we proceed to a specific kind of design. We have agreed that for IIR filter design, we shall follow the following process. We would first identify what are called the unnormalized specifications. Those would be given to us. These would be in the actual frequency domain, that is in terms of hertz, kilohertz, whatever. Here we divide these by the sampling frequency. And we get what are called the normalized specifications. And the normalized specifications are in the normalized angular frequency, which of course would be between 0 and pi, because you are of course going to design a real filter, and therefore what you have between 0 and pi is also going to be mirrored between minus pi and 0. Further, what we have as specifications are only the magnitude specifications. Is that right? So, only magnitude specifications. Phase response is just going to be a consequence of the design. We have very little control on it. We will just accept what phase response we get. Now, having got the normalized angular frequency specifications, the next step is to use the bilinear transform. So, we have already looked at the bilinear transform. So, and there we have the analog frequency capital omega given by tan of the discrete frequency by 2. And therefore, a range of 0 to pi maps into a range of 0 to infinity in this process of bilinear transformation. Now, one must remember that the so-called analog filter frequency that we are talking about here is only an intermediate design step. We would design the analog filter, we would meet the frequency response specifications in the analog domain, but we are not going to directly use that analog filter at all. And moreover, the analog frequencies that we get are not the frequencies